Hi everyone, this is your math guru. In this video, I'm going to show you how to solve the following simultaneous equation. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. For a simultaneous equation, we need two or more sets of equations that share common variables. In the example given, we are to solve simultaneously for x and y. 3 to the power of y plus 1 divided by 32 equals the root of 96x. You can see that this is one equation. So the first aim is to separate this equation so that I can derive at least two new sets of equation from what I have on ground. So the first step is to change all the whole numbers, that's 32 and 96, into base of its prime factors. So therefore, my equation becomes 3 to the power of y plus 1 divided by 32, changing that in exponential form will be 2 to the power of 5 equals, I'm going to do the same for my 96. So I have square root of 96, that's 2 to the power of 5 times 3. Note that all this is raised to the power of x. I'm going to rewrite that. That is going to be equal to the root of 2 to the power of 5x times 3 to the power of 1 times x, that is x. Rewriting that as a linear equation, I have 3 to the power of y plus 1 times 2 to the power of negative 5 equals, on the right hand side, I'm going to change my root sign, that's converting my surd to exponential form. So that means I have 2 to the power of 5x divided by 2 times 3 to the power of x divided by 2. So a quick recap is, if I have the root of x in exponential form, that's x to the power of 1 over 2. So if I have the third root or the cube root of x to the power of 2, to write that in exponential form, that's going to be x to the power of 2 divided by 3. So therefore, back to what we have on ground, you can see that on my left hand side, I have the base of 3 multiplying the base of 2. And likewise on my right hand side, I have the base of 2 and the base of 3, which are equal bases on both sides. So what I'm going to do is to equate the exponent that has the same base. So that means I'm going to equate the exponent of 3 on my left with the exponent of 3 on my right, and likewise the exponent of 2 on my left with the exponent of 2 on my right. So my equation becomes, for 3, on my left hand side I have the power of y plus 1 equals, on the right hand side, the exponent of 3 as x over 2. So therefore, from here, my y, making y the subject of formula, equals x divided by 2 minus 1. I'm going to tag that my first equation. On the other side, for my 2, I have on the left hand side negative 5 equals, on the right hand side, I have that is 5x divided by 2. I'm going to continue up here. So if I have negative 5, a whole number that's divided by 1, every whole number to convert to a fraction, I divide by 1. So that's 5x over 2. If I cross multiply, I have negative 5, or 5x times 1, that's 5x, equals negative 5 times 2, that's negative 10. I'm dividing both sides by 5 in order to solve for x. I have therefore the value of x equals negative 10 divided by 5, that's negative 2. So because I have the value of x, I'm going to substitute x equals negative 2 into equation 1. Equation 1 says y equals x over 2 minus 1. So therefore, replacing x with negative 2, I have negative 2 divided by 2 minus 1. That's negative 1 minus 1. Therefore, the value of y equals negative 2. So I've been able to solve simultaneously the value of x and for the value of y. Both are negative 2. Thanks for watching. Bye.